I'm picking up where I left off in number 28B as an example problem for finding net force and then acceleration using Newton's second law. We're decomposing F1 because it lays 30 degrees below the x-axis, and we want to combine it with F2, which lays directly on the y-axis. So I've got my components in the y and x direction for F1. If I wanted to, I could now redraw my diagram, x and y. I now have F2 of 16 newtons in the y direction. I have F1y, which is in the negative y direction. So I manually insert negative 5.1 newtons because I know from the diagram that it's pointing down. And then I have F1x, which I now know is 8.833 newtons. And now I can add my vectors. So I have 16 newtons up and 5.1 newtons down. F net y must be equal to 16 minus 5.1, so 10.9. And then F net x, there's nothing opposing 8.833 newtons, so it's plus 8.833 newtons. All right, and now I can find my F net by adding 10.9 to 8.33, 8.833. And again, either tip to tail or parallelogram rule. Our net force is the vector that points from the beginning to the opposite corner or from the beginning of one to the end of the second. Same difference. It's the hypotenuse of a right triangle with sides of 8.833 and 10.9. That's squared. So our net force looks to be 14.03 newtons. And really, if we're just keeping 3 sig figs, we should probably say 14.0 newtons. Direction, again, let's define it above the x-axis. So here's my theta. So I can say that theta is equal to the inverse tangent of opposite. So that's 10.9 divided by adjacent 8.833. And I have to go into my trig menu of my calculator to complete this. My angle is 50.979. Let's call it 51.0 degrees. Okay, so that's my net force, but again, I haven't quite answered the question yet because we're supposed to find the acceleration of this 18.5 kilogram object. So again, acceleration is equal to net force divided by mass. I now know my net force is 14.0 newtons. The mass of the puck, or whatever it is on this table, is 18.5 kilograms. And so for part B, our second arrangement of the two vectors, I have misentered the mass. So 14 divided by 18.5. I have a magnitude of 0.7567. So let's call it 0.757 meters per second squared. And again, the angle of the net force is the same as the angle of the acceleration, so 51.0 degrees, counterclockwise to the positive x-axis. That is supposed to be CCW. In any case, that is problem 28.